Now I'm gonna close the build.grade file because you don't need this file, and also I'm gonna hide the project pane, and I'm gonna add the main function. So I'm gonna press M, press enter, and by default the main function and the code within the main function is executed on the main thread. So let's add a comment here, executed on the main thread. So let's add a print line here, which is gonna say main program starts. Let's put colon, $, and we're gonna type thread that current thread. So this is gonna give us the current thread on which this statement is executed. That name. So it's gonna give us the name of the current thread on which this code is executed. And now we're gonna pretend that we're gonna do some work in the background, but we're gonna do this work also on the main thread. So I'm gonna, instead of, because we don't do actually that work, we're just gonna pretend. So we're gonna type thread, we're gonna put the thread to sleep for a few seconds. So we're gonna type thread.sleep 2000. So this, I'm gonna add a comment here, pretending to do some pretending here to do some work. So here we're gonna pretend that we're doing some work in the background, and then I'm gonna add here a print line, which is gonna say main program ends, also colon, $, and thread that current thread that name. So all the code that we have here, this code is going to be executed on the main thread. And because here we type thread.sleep for 2000 milliseconds, so we're pretending that we're doing some work for 2000 milliseconds. Now, when this line of code is going to be executed, the thread is going to pause, and then it's going to execute the next line of code. So if you run this code now, we get main program starts, and we get main, then we have that delay of 2000 milliseconds for 2 seconds, then we get main program ends, and we did this on the main thread. So as you can see, this thread.current.name, it's returning here main because the work is done on the main thread. But as you can see, this is not the way we'll do things, because this blocks the main thread for 2000 milliseconds. And imagine if you have here a function which performs a heavy operation, it will block the thread like I explained in the introduction video. What we can do is creating a background thread, and we're gonna put that thread.sleep, so that work that we're pretending to do, into that thread. So I'm gonna type here thread. So we're gonna type thread lambda expression, press enter, and we're gonna put this code. Now I'm gonna put this code inside here. But I'm gonna add a new few print lines. So I'm gonna add here print line, and I'm gonna type fake work starts, colon, $, thread that current thread that name. So that is gonna give us the thread on which this so this is gonna give us the thread on which this background thread is, on which this code is executed. And I'm gonna add also print line here. After we finish the work, we type fake work finished, also colon. I'm gonna type thread that current thread that name. So what we're doing now is we creating a background thread, and now we're executing that work that we imagine on this background thread, so that we don't block the main thread, the execution on the main thread. And this code now is going to be executed without waiting for that work to be finished, because now that work is done on the background thread. So now if I run this, as you can see, we get main program starts, main program ends. So this line of code is executed, then this background thread is launched, and then the execution of the code continues. So this code now doesn't block the main thread, and it says main program ends, and then we get fake work starts, and we get thread.0. So this is the thread on which this background work is executed, and then we get get fake work starts. I get the name of the thread from this that we have here, thread that 0, and then we get fake work finish. And the code on the main thread and the code on the background thread, it's executed in parallel. So in other words, it's executed concurrently. And that means that the code is executed in parallel. So the code on the main thread is not waiting for the code on the background thread to finish. No, it just executes this line of code. It sees here that there is a background thread, and then it goes to the next line of code and it's executed this line of code. So it's not waiting for the background. It's not waiting for this to finish in order to be able to execute this line of code. So this is why we get here main program start main program ends main, and then we get fake work starts our background thread, and then we get fake work finish. And now if you run this again, you'll see the same output. So you get main program starts, main program ends. So those two are executing in parallel with those two that we have here. And this is because we're using a background thread. Now, let's see how we can achieve the same thing using a coroutine. So instead of thread, I'm going to delete here what we have here, and I'm going to type here coroutine scope. Now, but before we create our first coroutine, I want you to notice something which is very important. So I'm going to change this back to thread. Now I'm going to run this code again. And we get main program starts, main program ends, we get main, then we get fake work starts, thread, fake work finish, thread. So we get our code executed in parallel, concurrently. And what I want you to notice is that even though this last statement was executed in our main function, our program didn't end there. The program waited for the background thread to finish the work, and then we get process finish with exit code 0. So then the application finishes. So by default, the application will wait for the background thread or for the background threads to finish their work, and only after that it will finish the application, it will terminate. So let's now change this back to coroutine scope. So we type here coroutine scope. I'm going to explain immediately what is a coroutine scope. And now the coroutine scope is expecting here as a parameter a coroutine context. But first, let's talk about what is a coroutine scope. So a coroutine scope is usually used when you want to group a bunch of coroutines together. So if you want to have a bunch of coroutines to be grouped together because maybe one coroutine depends on another coroutine, and if maybe one of the coroutine fails, you can cancel all of them. We can do that because if you use them, if they are in the same coroutine scope. So this is what coroutine scope is used for. It's used to group a bunch of coroutines together. So you can have flexibility. You can do things if something happens with one of the coroutines. Now, this coroutine context here you need to pass first what kind of work we're gonna do. So this is what we're doing with the coroutine context. We're saying to the coroutine scope what kind of work we're going to do and on which thread we want to do that work. So we have a few options. First is the main. So if I type main, now let's press Alt Enter, and we have this main.kotlin.is coroutines. Main means that this coroutine scope is gonna work on the main thread, but this main that we have here only works on an Android program, but now we have only IntelliJ, so we cannot use main. The next one is IO, and IO means input output, and this is used for getting data from the internet or querying a database. So this is when you should use IO. And you also have default. Default means doing heavy work. So if I put here default, you see that we have dispatchers.default. You can press enter, and basically what this means is that this coroutine scope is gonna do some heavy work, and it's gonna use it depends on the coroutine what kind of thread it's gonna choose from the thread pool. Next, you still have this error here because we need to launch the coroutine, we need to create the coroutine, and to do that you put dot launch. And if you feel confused by what I talked about here about the default and main, don't worry, because in the next videos I will go into much detail about them. So we put dot launch, and now this creates the coroutine. As you can see, it's this coroutine scope. Now if you run this code, you're gonna see something interesting. You get main program starts, and then you get main, the name of the thread, then you get main program ends, and you get the name of the thread. But we don't get our fake work starts and our fake work finish. Why? This is because by default the program does not wait for the coroutine to finish the work. In comparison with the thread, as I said, for the thread the application waits to finish its work, but for the coroutine it's not doing that. So what we can do? What we can do is that we can type here thread dot sleep, and we can put here to 5 milliseconds, and now this will make the thread to sleep for 2.5 seconds, and because this only takes 2 seconds, we'll get our output in the console. So if I run this now, but this is not recommended to do in a real app. So you get default dispatcher worker 1, and you get main program ends. So now our output works, our program works. So you get main program starts, then you get our fake work. So you get our work on the, which is on the coroutine, and then we get main program ends, and then the process. So now it's waiting because we said here explicitly to pause the thread for 2.5 seconds, and because this works takes only 2 seconds, then it will have enough time to finish this. But as I said, by default it's not waiting for the coroutine to finish. But if you think about this, is not a solution, because if instead of thread.sleep, because here you pretend you do some work, you have a function which is getting some data from the internet, you will have no idea how much time that it will take. So what we can do in that case? In that case, we will need to use something else, and I'm going to show you what you can use instead of thread.sleep here to wait for the coroutine in a short time. So now let's think about this thread.sleep that we have here. So if you think about our discussion when we discussed in our introduction about threads and coroutines and how they work, if you have a bunch of coroutines inside this coroutine scope that we created, because we have here thread.sleep, this will make the entire thread to pause for 2 seconds. And if you have 3 or 5 coroutines, all the coroutines will be stopped because the thread will be paused. So you need to use something else instead. So to use something else and to use to not block the entire thread, so the other coroutines can do their work, we're gonna use delay. And delay is used because it will only pause that specific coroutine. It's not gonna pause the entire thread, so the other coroutines can do their work without being stopped because the thread was paused. So if you use delay means just pause this specific coroutine, not pause the entire thread. Let the other coroutines to do their job within that thread and just pause this coroutine. So this is what it means. So if I run this, now we get main program starts main, then we get fake or starts, then we get our pretending work, which is this, which delays the coroutine for 2 seconds, and then we get main program ends. Now, as I said, in a real app, you'll not know how much time it will take for the coroutine to finish its work. So you cannot use thread.sleep and pass a specific number here, because you'll not know how much time it will take to do the work. So what we can do instead is we can delete this. So if you go up here and we press and hold Ctrl over the launch, and if you click, it's going to take us here, and we're going to see that this is an extension function and it returns a job object. And what is this job object? This job object basically allows us to have some control over a specific coroutine. So if I type here val, I'm gonna call this variable parent job, because this is where this is the parent coroutine if you want, because as you'll see later, we're gonna add some child coroutines inside our coroutine scope that we created. Now what we can do down here, because let's type parent here, because this job is offering us some control over the coroutine, we can, instead of typing thread.sleep and waiting for a specific time, we can say to the compiler to wait for this for the coroutine to finish its work and then finish the program. So I can type it parent job, and to make the compiler to wait for the coroutine to finish, we type parent job dot join, and this basically is gonna say to the compiler, hey, wait for this coroutine that was defined here, wait to finish its work, and only after that finish the application or the program. But we have a problem here, and if you hover over here, it says suspend function join should be called only from a coroutine or another suspending function. Anyway, this is also a suspend function, as you can see if I hold control on it. Now, what are suspending functions? Suspending functions are functions which are marked with the suspend modifier, and they are not coroutines, but they can only be called from a coroutine. You can never call a suspend function not from a coroutine. So as you can see, this delay is a suspend function, has the suspend keyword there. And now what we can do here because here we're not inside the coroutine, so we cannot call join, because you can only call a suspending function from a coroutine. Here we can use what is called a runBlocking, and runBlocking creates a coroutine, and we can put now this code here and paste it here. I typed run catching, not runBlocking, so let's change this to runBlocking. And now the error disappeared, because now this creates a coroutine, this runBlocking. The problem with runBlocking is that the runBlocking also blocks the thread, but this is the only way in which I can present the code. So in a real app, you're probably gonna just type parent job.join, and that is gonna work. But here you need to call this from within a coroutine, because this is a suspending function, and a suspending function can only be called from a coroutine. Now, if I run this code, look what happens, because now you said to the compiler, you said to the program, hey, wait for this to finish. Now we get main program starts main, fake word starts, and we get our thread on which the coroutine is operating, and then we get also our thread on which the code is operating. Another important thing to know is that even though the coroutine is operating, let's say, on this thread when it starts, it may happen that when the coroutine ends, so when you execute this line of code to do the work on another thread. So this is also important to know. And now if I change this to, let's say, 5 seconds, and if I run now, because here it said parent job.join, so wait for this coroutine to finish its job, it's gonna wait 5 seconds, then it's gonna say fake word finish, then it said main program ends, and we get main. Now I'm gonna close the console, and I'm gonna continue our discussion in the next video.